Joel?
Hello. Yeah, as your professor said, I work at Gentex Corporation. Well, when I started, we were a relatively smaller company. We had, I think, I'm employee number 1,900. We're currently at 3,600, and we've got, I'd say, at least another 500 positions opening up. So things are going a little nuts over at Gentex. What do we do? What's this company like? Well, 1974 we started making smoke detectors. Small little tiny building off in the corner of Holland, and eventually we wandered over to Zealand. And like I said, we're currently at 3,600 employees. We were, I don't know, maybe just under 3,000, maybe 2,800, and then we had the economic turndown. We had to lay off a few people, first time in our history that we had ever laid off anybody. And it was a year before you heard about any type of recovery anywhere else in the news. We had already been hiring. And we've hired, just in the last year and a half, 1,100 people. So things are growing really, really quick. We'll cover as to what is making our life crazy right now at Gentex. There are three main areas, though, that we specialize in, and they all have one common theme, and that's electro-optical products. That means the combination of electronics and something to do with control of light. First thing we started off with was fire protection, photoelectric smoke detectors, and now we're starting to get into CO detectors, carbon monoxide. It branched off into automotive with auto-dimming rearview mirrors. And then we finally got into aerospace, windows. So let's learn about a little bit this. I'm going to first tell you about the company, what we work on, what we do, how we've grown, and then how does chemistry relate to any of it. Because if you look at what we work on, what we make, you'd never know that we have a chemistry department and that we have some of the most advanced research in all of Michigan occurring right over in the Zealand area. We're headquartered in Zealand, Michigan. This is the main headquarters right here, our Centennial plant. We have two other plants. Those are the three main plants. There are many other support buildings. We have 4 major expansion projects going on right now. The 2 buildings off in the right there, they bought out, I think, 4 businesses, and they're connecting them. We have an electronics facility couple miles away. They are doubling the size of that. We have another warehouse that is actually going to be tripled in size and is going to house all of our chemical production and some storage. What used to be junk warehouses are now major warehouse distribution sites. And we have just over 1 million square feet in covered building space right now. That will be doubled within the next 4 years. And that's just trying to keep up, and nothing more than that. We also have sales, engineering, and light manufacturing sites in Germany, Japan, China, and sales offices in, I think, 4 or 5 other countries. We're worldwide. We've got customers everywhere. We've got plants everywhere. But almost all our manufacturing is done right here in Michigan. We are, I think, the largest electronics manufacturer in Michigan, if not the entire Midwest. We build millions of printed circuit boards every year. What do we work on? What do we do? Well, these are some of our core competencies. CMOS imaging, video cameras. Well, we have a product that's really taken off and is expanding, and so we're doing a lot of digital imaging, all the software involved with that. We have electronics design, printed circuit board design, mechanical design, microelectronics, so silicon wafers, we're working with them, using those as imagers. We've got microphones, because our mirror products might have a microphone in it for interacting with your telephone. And then glass processing. We bend glass, we cut glass, we wash glass, we coat glass. We build glass into the parts that we build and sell, and then we have chemistry, and that's where I'm involved. Like I said earlier, fire protection is how we started. We're going to get rid of this little window here. Back in 1974, we came up with a new type of smoke detection technology. Most smoke detectors in everyone's home is based on ionization. There's a small radioactive source, and it detects smoke particles floating through the air. They work really, really well with what's considered a fast fire, like a grease fire in your kitchen. That thing will go off. But if you fall asleep in bed, you are smoking, mattress slowly smolders for a few hours. It can literally be hours before that smoke detector goes off. That's what's considered a slow fire. The particles are much larger, and they're actually harder to detect. We came up with a technology where we detect them very, very well. It's a little more expensive, a little more complex, but it works very, very well, and that was the start of the company. We have many of the Disney properties all over the world have our product in them, the hotels. The casinos in Vegas are another major market for our products. They're a little more expensive than you would typically find in a home. That's why you don't typically find them in homes. They work, but most people, they just want a smoke detector. How are we going to expand our company we're making smoke detectors? You can't really make that many. So start looking around at what we work on, what we're good at, and headlamp glare was one where we were thinking, it's like, well, maybe we can do something with headlamp glare. You know, you're driving down the road at night, someone comes up behind you with their bright lights on, or a big pickup truck where it's just a lot higher than your car. Comes up, you can't see. It's coming into your rear view mirror, it's coming in your side view mirrors. It's like, what do? Most people have the little flip button on their prismatic mirror, and you flip it, and you can see again. You still have your side view mirrors. You can typically get a fair amount of glare coming out of those. Well, the original technology were these prismatic mirrors. You just flip the little lever. Our engineers started looking at that and like, well, we have light detectors. What can we do about that? So they came up with our first iteration mirror back in 1982, where there's a little light sensor looking behind you. There's a light sensor looking in front of you. When the light sensor detects more light behind you than ahead of you, it sent a current to a little motor right here, and it would flip your mirror. That's it. You don't have to reach up and flip the lever anymore. It worked great, except it was annoying. It would go all the time. And that little motor was connected to the mirror with a rubber band. How well do you think a rubber band lasts? It doesn't. We were repairing these things all the time, but for 5 years, this is what we sold. The company started growing. Well, we got to come up with something better. So in 1987, had a couple chemists come up with a technology that, same thing, these things were auto-dimming, but rather than flipping a little prism, which darkens your mirror, it sent an electrical current to what was basically two pieces of glass with a small amount of a gel in between them. And when you apply a current, a voltage, to them, it darkens. And the amount of that voltage that you send determines on how dark it gets. And so in 1987, we started coming up with these auto-dimming rearview mirrors. And 4 years later, we came up with outside rearview mirrors, because as soon as you start blocking out the glare in your rearview mirror, guess what stands out really, really well when someone comes up behind you with bright lights? Your side view mirrors. And so we came up with those 4 years later. Can anyone think of a reason why an outside mirror would take 4 years longer to develop than an inside mirror? Any idea? It's not protected from what? Elements. What's one of the biggest things you are concerned with like paints, vinyl siding, things like that? What affects the color outside? The sun. There's a lot of ultraviolet light out there. It took us 4 years to figure out how to protect the chemistry in these mirrors to have them last long enough for outdoor use. If you look at what the thing is, you have just a plastic housing here, a circuit board, and then the electrochromic element right there. You still have a light sensor that faces to the back, light sensor faces to the front. You have all the electronics to handle that, and we have patents. We filed that, we protected it, and we protect everything. We file anywhere between 50 and 100 patents per year. Very, very important if you're in a company. You need to protect what you're working on. If you don't, someone else can actually protect it and stop you from manufacturing and selling your own product. So if you don't protect it, well, you're just asking for trouble. How do these things work? Well, just like that little prismatic mirror, you have what's called glare, someone's bright lights coming up from behind you. There's a light sensor somewhere in this mirror, and it detects that amount of light. It's looking forward also, detects the amount of light ahead of you. Because you're driving at night, you have your headlights on, but it's not real bright. And as soon as it sees there's a differential, it applies a current to the electrochromic element and darkens it until the light levels are balanced. Pretty simple idea, it's pretty complex. But as soon as we started making these products, say, what else can we do? Because where is this mirror in your car? It's in a central location. It's pretty close to where your head is. It's mounted onto the windshield. It can look forward. It's looking back. It can interact with the side view mirrors. It can look at things to the side. It can interact with any other type of sensors in the car, because the other great thing about it is right where you naturally look. It's a great place to have a display. And so we just started putting all kinds of products into a basic rear view mirror. We've got, that's a little messed up, but we've got everything from just the glare management, the electro dimming thing. We've got displays. We've got OnStar is one of our products. Compasses, thermometers. You can tell what your temperature is outside. Do you have to worry about ice being on the road? Like if it's 35 degrees when you start driving, it drops down to 32. How would you know that all of a sudden those wet roads are all of a sudden going to be icy? Well, if you have a thermometer in your car, you know. Yeah, you could have it in the dashboard, but it's really convenient just to have a little tiny display up in your rear view mirror in the corner. Side blind zones. Our vehicles can detect if there's someone in your blind zone on either side. And then as you're going, you might look in your rear view or your side view mirror. You might not see that person, but all of a sudden you see a little symbol of a car. That's telling you that there's actually a car in your blind zone. Lets you know, increases the safety of the car itself. We also have what's called forward driving assist. We have a CMOS camera mounted in the base of the mirror, looking forward, and it can tell if there's headlights there or not. Flips your bright lights on and off, all automatically. And then we also have what's called the rear camera display, which we'll show a little bit more. So yeah, you have displays here, temperature, compass, the rear camera display. I just got this in my new vehicle. I've got a truck. You can't see behind a truck at all. Or even if you're backing up to a trailer, you can't see the hitch ball. So you go back a little bit, get out, got to go a little further back. There's now a camera that you can mount somewhere in the back of the vehicle, whether it be on the tailgate, next to the license plate, and it looks behind you. The main thing is it's a safety factor for kids. You cannot always see if your kid or your kid's bike is right behind your vehicle. You get in the garage, you back up. You didn't realize they came running out after you. They're still coming around the car to give you a kiss. They get run over. There are, it's in the hundreds as far as the number of kids every year that get hit by their own parents or sibling in the driveway, in the garage, from the drivers backing up and never sees the child behind them. You have one of these cameras mounted into the back of your vehicle. You put the car in reverse, and you see this. It looks like a rear view mirror, right? That is nothing more than a rear view mirror, but the second you put it in reverse, there's a little LCD display that pops up and actually shines right through the reflective surface of the mirror and shows you exactly what's behind you. This has been what is really driving all of us crazy at Gentex right now. It's exploding. Everybody wants this product. In 2014, there's going to be a new regulation that requires this technology in all new vehicles. Now, you could have a navigation system and you can show the display in the navigation system. Great. How many of you guys have a car that's expensive enough to have a navigation with a large display in it? Hardly any of us have that. That's only your highest end vehicles. Our product, everyone's got a rear view mirror. Stick it right on the windshield. You don't have to modify the dashboard. You don't have to do anything. As soon as you put it in reverse, that display pops up. It's instantaneous. It doesn't have to boot up like a navigation system will take anywhere from 30 seconds to 3 minutes to boot up. Do you want to get in your car in the morning, start your car on and wait for 3 minutes for your navigation to start up and then see if there's something behind you? No. You need instantaneous response. And so that is one of our biggest products that's taking off. We also can put interior lighting in, can put turn signals in the side view mirrors. And then this is our mirror here that has a large camera mounted in the base. And that is what we call Smart Beam. That camera can tell the difference between headlights, street lights, stop signs, tail lights, and it can tell if it's a car ahead of you or if it's just a reflection off your own headlights off a stop sign, and it will flip your bright lights on and off automatically. I believe people have been shown that they only use their bright lights 20% of the time that they could use them. Because it's a pain. I mean, you're driving down the country road, you're flipping them on, you're flipping them off, you're flipping them on, flipping them off. Most of the time, you're just going to leave them off. You're not going to bother with that. And you really can't see that well without those brights. This does it automatically. And it can also, depending on the technology of the car, cause them to fade down or fade back up. And with this product, we have really started looking into new markets. If you're departing from your lane, it's looking at the reflected lines on the road, and it can warn you, hey, are you like falling asleep and set off a buzzer depending on what the manufacturer wants it to do? Like you're departing your lane. Do you want to depart the lane, especially if you don't have your turn signal on? So there's a lot of technology that we can put into what's just basic rear view mirror. And why? It's because we got into the market with this new dimming technology. It opened the door, and we just went off with it. Now, we're growing in the automotive market. Everyone knows the automotive market's up, down, up, down. You never know what's going to happen. How are you going to grow? Well, we make these mirrors that, here you can actually pass this around. Just hold the button down and you'll see it darkens. We need to get into other markets. It makes our business a little more stable if you're covering several different fields. That way, if one market's slow, then you're still making money in another market. So the obvious choice would be, well, let's try windows. This is, right here, the window from a Boeing 787. That's a little bit bigger than a mirror, isn't it? So, well, 1987, these mirrors came out. 1991, the slightly larger outside mirrors came out. These only came out a couple years ago in 2008, 2009, we started producing these. This is a much, much harder product to build. Like I said, it took 4 years to develop the outside mirrors because those mirrors are exposed to sunlight during the day. Well, they're exposed to sunlight and all the elements during the day. Well, guess what? They're still clear. The chemical inside isn't darkened. A window is not only going to be on during the day, it's going to be on at altitude where there's a lot more ultraviolet light. There's a lot more everything up high. It took us a long time to figure out how to make the coatings, how to really bulletproof the chemistry so that it doesn't degrade, and to get the performance that we needed for a window. And so we're now making aerospace windows. How many of you guys have flown? Everyone been on a plane? Yeah, what do you have if you want to darken your window? A little shade. Believe it or not, that little tiny shade is one of the largest maintenance nightmares for an airline, for everybody. Those things break all the time. You want to know what you have to do to fix them? You have to pull out all the chairs for a couple rows. You have to take out the entire panel from floor to ceiling. Then you can finally access the track system and the plastic shade just to replace it. It's a huge pain. And they're like, we need something that's going to last longer. So we came up with this technology that you have complete control over the amount of light. You can have it almost completely opaque, or somewhere in between. So not only can you block out some of the light, but they're like sunglasses. You can actually still see the scenery outside, but not have it be so bright. So you can look at the mountains below or the ocean or whatever, but it won't be shining really, really bright. If you're on an international flight where you have to, you're going to be going through the night and you have sunrises, sunsets, and it's like, all right, it's movie time. We need to darken the plane. The flight attendants, they're going to go and they're going to reach down and shut all the windows or ask everyone to shut them. Now they just go up to a computer control in the front of the plane, hit beep, all the windows darken all at once. They have complete control over the entire plane. Or they will maybe narrow it down so, okay, you can only look at maybe 20% transmission down to 0.001% transmission. You can't have it at the higher values. And very low maintenance. These things, you're not going to be dragging things up and down, and they're also very lightweight. So we have two announced plans or customers, the Boeing 787 and the Hawker Beechcraft King Air. So we have the top of the line commercial jetliners, and we have what's considered the very bottom of the line or at the lower end of the business planes. Well, where's your market now? It's everything in between too. So we are working on getting a lot more customers everywhere. The 787, why is that plane so cool? Well, its first commercial flight will actually be next Wednesday. So this is kind of neat timing and the first time I've ever been able to say this. It's Boeing's newest commercial jet. Most commercial jets are all aluminum. This one's 50% composites, graphite composites. It's plastic, basically. It's lighter. It's more fuel efficient. They can run it at higher pressures inside, so you're going to feel better. Just higher humidities. You're not going to be so exhausted after a long flight. Less turbulence. And I think they're saying it's going to use between 20 and 30% less fuel than equivalent size planes. So this is a really, really big plane for Boeing. And it was the first plane to have these electrochromic windows. So we're really excited to be able to get into this. How big are we? Well, here's some numbers here. Back in 2008, we had $624 million in sales. We had the turn down in 2009, $544 million. You can see we're at $816 million last year. This year, we're going to hit over $1 billion. We just had our last quarterly announcement yesterday. We had almost $70 million in sales over the last 3 months. Things are growing really, really fast. Last year, we invested $64 million in research and development. Why is that an interesting number to you guys? That's what pays me. That's what pays the chemist. That's what pays for all the equipment that makes these products. You need to be constantly at the front of research and development. And oh, that's too bad you can't see a lot of this stuff. Can I? How can I do that? On this thing? On my computer? Oh. See, that doesn't anything. That didn't do anything. Huh. All right, well, so our profit margins, 35%. So not only do we sell a lot, we got a high profit margin. We're making a lot of money. We have $350 million in just cash, just sitting right there. $130 million in long-term investments, 0 debt. Our total assets are over $1 billion. I mean, this company, when we had the turn down, the only reason we had layoffs is we had nothing for people to do. 50% of the business evaporated like that. We weren't worried about the health of the company. We have no debt. We have plenty of cash. We just had nothing for people to do. So as soon as things started picking up a little bit, we brought people back and we started putting in equipment. We caught up on a lot of processes that had not been optimized, that we were running into yield issues. We fixed all that, and we were ready to go as soon as things picked up, which is good because they're going even faster than we ever imagined. If you look at since the very first electrochromic element was shipped out in 1987, all the way out to 2010, we've averaged 19% growth year after year after year. And Yeah, it says right there last year had about 17 million mirrors that we shipped out, and this year we're looking at probably closer to 22 million mirrors. We have a lot of mirrors. All right, so how does chemistry fit in to Gentex? We're going to have to cover a couple terms. I've told you about we have an electrochromic gel. Well, one first term that we're going to cover is electrochemistry. It's a branch of chemistry that deals with the behavior of molecules or atoms and chemical reactions that occur under an applied voltage or current. Basically, if you run electricity through a sample, what's going to happen to the molecules in that sample? Now, we have to take that and go to electrochromism. Well, it's an effect that the electrochemistry, basically, the effect is it turns color. So if you have a certain amount of compounds or a certain type of chemical in your solution, you apply a current, you actually go from one color to another color. You can control that color based on the chemistry, the molecules that are in that solution. And that's what we do. All right, so first we're going to cover some basics of electrochemistry. We have reduction, some type of material. It could be neutral or it could be charged already. When it's reduced, it gains an electron. And an example of this is, has anyone ever done the silver Coke bottle demo type thing? You can put a series of chemicals into a glass Coke bottle, which, yeah, not always easy to find. You mix it up, and you're plating what's a silver ion from silver nitrate onto the surface of the glass, and it's mirrored. You have a silver Coke bottle. And it's a reduction of the silver cation to silver metal. Now, the other thing is oxidation. That's when a material loses an electron. So either have a neutral material, loses the electron, becomes a cation, or it's already negative, it loses an electron and becomes neutral. An example of oxidation. You live in Michigan. What oxidizes if you live in Michigan? Your car. It's the rusting of iron. You have metallic iron or steel, reacts with oxygen, catalyzed by water, salt, everything else, oxygen, forms iron oxide, rust. That's an oxidation reaction. And guess what? In order to maintain charge balance, if something gets reduced, something else has to get oxidized. So, all right, so we know about reduction, we know about oxidation. Now we're going to cover some electrochromic materials. Oh, I don't have, We have here ferrocene. This is the same molecule which you can't see here, but it's basically neutral. This is normally light orange, and when it gets oxidized, it turns blue. So if you have this thing in solution and then you add something that rips an electron out of it, it goes from a light orange in solution to a nice blue color. This is a film. This is called tungsten oxide. If you oxidize it, reduce it, you add an electron, it turns blue. And if you take that blue tungsten oxide and remove the electron, it goes back to tungsten oxide, neutral. Ferrocene is the same way. It's a reversible process. Here's a methyl viologen. This is a purely organic type compound, meaning it's just carbon-based material. It's a dication, and when you add an electron, it turns blue-violet, hence a viologen. And so compounds like this are what we can use to make an electrochromic product. This is an EC element right here. It's just two pieces of glass, and they've got coatings on them with a gel in between. So if you look at what this is in the case of a mirror, we got the two pieces of glass. The back piece of glass has a metal coating on it, whether it be chrome or it's something that's reflective and it's conductive to electricity. Most metals are. But it also has to be chemically stable to what we have in the element. In the front, can we have a metal? No, you can't have a metal. We need something that conducts electricity, but it's got to be transparent because you need to see through that surface to see the gel and the reflective surface in the back. What we have is called a transparent conducting oxide, a TCO. It's a ceramic. This ceramic is transparent and it conducts. Examples are indium tin oxide, fluorine doped tin oxide. You know, I've never heard of this stuff before. Does anyone have a phone or an LCD TV at home? Or heck, an LCD on your computer? ITO is probably the most popular transparent conducting oxide in the world because it's used in all LCDs. It's used everywhere. Well, guess what? Indium is actually really expensive and quite rare. So if you can find a replacement for that, something that's transparent and conducts electricity, you will make a lot of money. But that's a whole other project. Well, between these two conducting plates, we have the gel. This is some type of material. It's got compounds in it that change color. They're either colorless or they change color when you apply a field. It's got maybe some UV stabilizers in it, some other things. And yeah, when you apply a potential between the two conductive surfaces, boom, it changes color. So what's happening inside? Well, at 0 volts, you have to have at least 2 molecules. If you remember what I mentioned earlier, you have something's got to get reduced, but if something gets reduced, something else has to get oxidized. Something loses an electron, something else has to gain an electron, because you can't just generate or take away electrons and have them poof in the air. So you have 2 compounds at minimum. One of them is going to go to the cathode and it gains an electron. When it does that, it becomes colored. The other molecule goes to the anode, loses an electron, becomes colored. Now, these continually diffuse through the solution. So they go to the electrode, then they kind of float back out into the gel. When they meet up, they swap that electron and they both go colorless again. Well, how are you going to maintain color? Well, as long as it's plugged in and you have a current or a voltage, in this case these things are running anywhere between 1 and 1.2 volts and a few milliamps of current, not much. As long as you keep on applying power, this cycle is going to continue and the part will stay dark. But now, the second you take off the power, these things continually diffuse through the solution, they meet up with each other, they swap their electrons, and they clear. And so it's a great safety thing. If you happen to lose power to your car or all of a sudden a wire breaks, your mirror will automatically clear. It's not going to stay dark and cause a reflecting safety hazard. And that's one way that we can get away with using this technology for products like this. We've patented these things. I mean, everything from it's a single compartment. It's just basically 2 pieces of glass with a seal, an epoxy seal holding them together, and we fill it with gel. They erase by themselves. It's a solution or a gel phase. We find we have to use gel because otherwise you run into a lot of issues, especially with a large window like this. If you have these 2 very, very thin pieces of glass filled with liquid, well, over time, the weight of that liquid sags and can actually blow out the bottom of the window. If we gel it, it goes in as a liquid and it turns to a polymer, and it's kind of liquidy, snotty-like. It sticks to the glass, and you don't have that problem with what's called hydrostatic pressure. Advantages of these things: long, long, long cycle life. We test these things for hundreds and hundreds of thousands of cycles. These windows in the planes, 10, 20, 40 years. We're still trying to figure that one out, but I think we have a 10-year guarantee. But we're thinking they're going to go a lot longer than that. They're stable to the environment. They can get hit with ultraviolet light. They can get hit with high temperatures, low temperatures, high humidities. We can tune the color from anything from a bright green, a red, a very nice neutral gray, purple, blue. It's just a matter of tweaking the chemistry to get whatever color the customer wants. And they're fast, and yeah, they don't affect the image. All right. So that's a little bit about the chemistry, a little bit about the products. Now, how does this apply to us? This is like, okay, you're the chemist, we're developing this, but what kind of person does this type of thing? Well, we've learned that we can take simple molecules. We make all this stuff right here in Zealand, put them in the mirrors. We can make a nice product that increases the safety of drivers, enhances the comfort of a plane, or we have the smoke detection, makes the house safer. And these simple inventions can make a lot of money. Now let's see who does this. Well, in the chemistry group, we have, my group is the chemistry R&D. There's two divisions. There's the synthetic group and the analytical group. The synthetic group is anywhere from PhD scientists all the way down to high school educated technicians and everywhere in between. And we're the ones that design the gel and all the components that go into it. We're the ones that figure out how to make that gel and all those compounds and how to scale it up. And then we're also looking at new products. I've been at Gentex now for 9 years. I have done almost nothing with the electrochromic technology at all, even though my whole group has developed that technology. It's just nature of what I work on. So we are doing research into products that we're not going to sell tomorrow, that we're not going to sell in a year, but that we're going to sell in 5 years, in 10 years, even in 15 years. If you're not preparing for the future, you're not going to have a future. Then we have our analytical chemistry department, which, has anyone ever seen CSI? You know, you go see a CSI and they got all that lab equipment and they, oh, we know what this is and blah, blah, blah. This is what the analytical team is. They've got between $3 and $4 million of equipment, anywhere from electron microscopes, IR, mass specs, liquid chromatography, and they figure out if there's a contamination issue in a product. They can figure out what it is, where it came from. We can test our competitor parts, because you want to be in the front. We have 85% of the electrochromic auto-dimming rearview mirror market. How do you keep that 85 and maybe get it up to 100%? You figure out what your competitors are doing and always stay a step ahead of them. How do you do that? You have to test their products. And then also if we have parts that fail, like whether it was already at the customers, like you bought a car, your mirror turns blue. That will get sent back to us and we figure out exactly what happened. Did the manufacturer plug it into a 12-volt battery and fry it right there? Did we have a seal failure? We know exactly what happened to it once we get it. We can analyze it. Then we have the applied materials group. This is a separate department in our company. Is a much more broad group. They handle the coatings. They handle the chemical production, the large-scale manufacturing levels. Like we'll make a few grams, maybe a kilogram of material. They're making hundreds of kilograms of material. They're coating thousands and thousands of square meters of glass. But they've got all levels of chemists there too. They make the seals, the plugs, because you have the seal around the outside and there's a hole at the bottom. We fill it up, you got to plug that hole. They've developed all that. We work very closely with that group because it's one product or one basic class of products, and we need to be able to, like our fluid might interact with their new coatings. So we work with them, we test stuff, and make sure everything's happy. All right, this is how we're going to design a new molecule. This is the process. We have these compounds, these molecules in this product that are going to turn blue, they're going to turn green, whatever. We need to know what color is it going to turn at. We need to know what voltage it's going to actually switch from colorless to colored. You need to balance that in the part. We need to know, is it stable? So we're going to design these things. We start off with computer modeling. We have a series of molecules, like classes, that we kind of have general ideas of how they're going to behave. And we start with those. Then we start tweaking them. We add substituents, functional groups on the side, or a couple extra rings and things like that to tweak the color, tweak the stability. So then we've got it designed. Now we're going to make it. Can we make it cheaply? Can we make it in one step, hopefully? You don't want to have to make 200 kilograms of material in 10 steps. You need to be able to make it 1 or 2 steps. And if you have any questions, feel free to scream anytime. And can we make it in high yields? That means with all the stuff that you put into it, can you get 90% of that back in your final product, or do you get 10% of that back in your final product and have to throw away thousands and thousands and thousands of dollars of useless chemicals now that cost millions to dispose of? So we need to be able to get the yields up. And is it safe? Or is the manufacturing process going to be very dangerous, risks of explosions? And so we're constantly trying to keep track of all that. If it makes it through the design, makes it through the synthesis, now we have to characterize it. How are you going to characterize it? Well, we'd send it off to our analytical group. Is it what we expect it to be? Is it pure? Is it at the desired voltage of oxidation or reduction like we expected it to be? Are there impurities? You can make a beautiful compound, would work great, but you've got a few ppm of something, parts per million, of some impurity that if you don't know that that's in there, you can actually throw this very, very good product out because of that impurity. We want to know what's in there, what it is, and how it's going to affect the material. If it makes it through all those steps, then it gets into parts. These are parts. Actually, we usually go a little bit smaller than that. We fill up parts, hundreds and hundreds of these things, run them through testing. Are they going to survive? They're running through minus 40 degrees Celsius. They're running all the way up to 125 Celsius. These things are getting hot. They're under, some of our test chambers can put 2 suns worth of ultraviolet light into your product. So you've got this really intense ultraviolet light and this sphere of all these parts that just sits there and rotates at like 60 degrees Celsius, just getting blasted with ultraviolet light. Because we don't have enough sun here to have all your parts up on the roof and like, hey, are they going to survive? And then it's like, okay, they survive a year. Okay, they survived a year in Michigan. That's not a year in Arizona. And we don't have a year to wait. We need to get 7 years of data in 2 months. So we have these facilities that we can do that in. Now, does it fail? If it fails, these parts turn blue and they don't clear. Or they turn yellow and they stay yellow. Or they blow up. Why? They go to our analytical group for autopsy. Remember what I said, CSI? That's what these guys do. They bust these things open. They separate all the components in the gel. They figure out what happened to that molecule. We have the capabilities of, oh, this molecule, this ring ripped open right here because some other compound came in and just caused a chemical reaction. Well, synthetic chemists were like, well, let's tweak this molecule and stop that. So we'll make the new molecule and stop that reaction, and all of a sudden, boom, you go through the cycle and it passes. We now have a new material that we can put into production. And we've relied on the same 2 basic compounds for years for our rear view mirrors. And it gave kind of a darkish, greenish tinted color. Looked great. When we put it in a window, it looked awful. We have one whole wall of windows in our lab that we put the automotive technology into all those windows. You flip it on and immediately you're depressed because you're looking out and it's this bluish, greenish color, and it's not a pleasant color. And like, we've got to change this. We very rapidly started looking into other compounds, and we now have 3 completely different dyes or molecules that are electrochromic and are in the windows that give a completely different color. And even this window is different from what we have coming out shortly. So we have the capabilities of tweaking that. Synthetic chemist group, chemists, chemical engineers, technicians, like I said, anywhere from high school to PhD degree. You get an associate's degree here. We have room for people with degrees like that in my group and even in my company. We have 8 or 9 PhDs in my company. Most people don't realize that we have that level of education within a West Michigan company, let alone in a company like this. We specialize in the small-scale preparation of these chemicals, and then we scale those up so that the applied materials group can then produce them for production. And then we also, if there's an issue in production, we can help with that, and then we also develop new products. And then with the analytical group, same level of education, anywhere from a high school education, associates, bachelors, masters, PhDs. They're testing all the chemicals that come in, all the products that we make. They're looking at returns that come from the production floor. Something just didn't look right. Returns coming back from customers. They look at contaminations. Here's an example of a contamination issue that we had at one point. A piece of glass came in and it had defects, like little specks of like a reddish material underneath the coating of the transparent conducting oxide. It was between the glass and that coating. And our group They brought it in, they looked at those specs, they put them under FTIR, infrared microscopy, and they were able to determine that it looked like a polypropylene. It's like, how do you get a polypropylene on a piece of glass underneath a ceramic coating? So they wandered down to the coating department, and they started looking around at the giant coaters, and these coaters are huge. These are like tractor trailer truck size coaters, and there's 4 big ones, and that's the main glass, but then there's other coaters around. And they started looking around, and they found a red broom. What is this broom used for? We sweep out the coaters between runs. Really? It was a broom with red bristles, polypropylene bristles. As they're sweeping out the inside of the coater, there's little flecks of this plastic from the bristles that are basically falling off the broom, and they're just scattering throughout the coater. When the glass comes through, they stick to the glass, the coating comes on, the glass is defective because it's got little chunks of polypropylene. Problem solved. Get rid of the broom, we no longer had that defect. If you didn't have the group to figure out where that red polypropylene was coming from, what are you going to do? I mean, they would check everything. The broom would probably be the last thing they'd think to look at. This is what the analytical chemistry group does. These are the instruments that they do with them. And yeah, we're basically doubling the number of all these things. We have electrochemistry. These, it's just a little box, and it can apply a voltage and measure a current, apply a current, measure a voltage, and apply it in a linear ramp and stair steps. This is how we test all these compounds because we're doing electrochemistry. That's what this product is. UV vis, IR, temperature-based measurements, whether it be TGA, that's where you're going to be basically burning something or heating something up to real high temperatures and watching how the weight is reduced. So like it's a milligram at this temperature. As you heat it up to 800 C, how quickly, or how, it's stable to 300, and all of a sudden you see this massive weight loss because it's burning. Differential scanning and calorimetry. What temperature does a polymer melt? How much does something expand with temperature? We have chromatography, GC, with mass spec. So you inject a volatile compound, and it separates out this compound or a mixture of compounds, and then you can take the mass of each one of those compounds, figure out what's in that mixture. We can burn something and test all the gases that come off. We have liquid chromatography, so maybe it's not volatile, it's a salt. We can inject that into an LC, separate out a mixture, figure out what the mass is of everything. That's how we figure out our competitor products, contamination issues in our products. We have IR microscopy. We have a scanning electron microscope. You can look down into a couple nanometer size magnification. So I mean, something's like 5 nanometers in size, we can see it with an SEM. We have XRF, X-ray fluorescence. This can look for elements of contamination. I mean, it'll see sulfur, it'll see cadmium, lead, things like that that might be contaminating your product or other products. And then rheometry, which is measuring the viscosity, the thickness of liquids, of epoxies, of gels, things like that. You may have been exposed to some of these right here. We use all this stuff. If you've been exposed to it here, you're going to see it in industry. It's not just in an academic setting. These are used in an industrial setting, all these instrumentations. Yeah, the electrochemistry. All these electrically active compounds we have to test for both QA, QC, for research. We need to know when they're going to get reduced or where they're going to get oxidized. We use a lot of this stuff. IR, contaminants, new molecule identification, UV vis. I mean, this thing's colored. Well, okay, it looks dark, but is it a dark gray? Is it a dark blue? Is it dark purple? We can tell where there's gaps in the visible absorption because it's like, okay, it looks kind of dark gray, but then you run a UV vis of it, and you see there's actually a big gap somewhere, I don't know, 470 nanometers of light. And it's like, well, that's not great. Well, when you look at it in really bright sunlight, you can actually say, yeah, this thing's kind of greenish, bluish. And it's because of that big hole in the absorption. Now we'll make a new molecule with an absorption somewhere in there, and boom, the part looks gray. GC mass spec, again, The mass spec is for determining the molecular mass of the compound. If you know what you make or what it should be, you can figure out what the mass of that should be, how many grams per mole of that molecule. Mass spec tells you the grams per mole of the molecule you made. Do they match? Do they not match? And you can figure out if things were successful and how pure mixtures are. If you inject something and it's like, oh, there's only one peak, great. Oh no, there's 8 peaks. Yeah, you got some impurities. Why? Liquid chromatography, same thing. This is thermal analysis. This is where we have an epoxy, basically a glue, holding these 2 pieces of glass together. Well, when you heat up glass, it expands at a certain rate. Guess what? If your glue does not expand at the same rate, let's say it expands more or expands less, now you create a lot of stress on that glass. Boom, it cracks. Because you've got 2 compounds that are bonded together that do not expand at the same rate. It creates a lot of stress, and you get loss of adhesion, part failure, not good. With thermal analysis, we can actually tweak our chemistry of the epoxy, get it to match the expansion rate of the glass. We can measure plastics in our molded parts. How much are they going to expand or contract with temperature? Are they going to stay assembled, or are they going to fall apart? Things like that we can use with these instruments. XRF, impurities. This is kind of wild. This will take a sample. It'll hit it with X-rays. And when a compound is hit with X-rays, it actually fluoresces in an energy. And if you look at that energy, you can separate out the peaks of the fluorescing energy, light coming off of it, and figure out what kind of elements are in that thing. So if you have a circuit board, this is a circuit board right here from a Boeing 787, a lot of stuff like that. You're going to sell this in Europe. They do not want cadmium, lead, any heavy metals. It's the RoHS standards. Well, how are you going to prove that you don't have any of that in? You can put it in an XRF and say, see, there's no lead in here. There's no cadmium, because you can detect down into the ppm range of what elements are on this surface. Or you can take a liquid or a plastic, put it in the same machine, do the same thing. When, I don't know, several years ago, the Little Thomas trains, when they had all the lead in the paint issue, we can have seen that lead very easily. Just by putting one of those things into this machine, we would have seen the lead peak come right up. We could have figured out how much lead was in it. And yeah, pretty easy. Microscopy, we've got both IR, visible light, and also the scanning electron. So with the scanning electron, how many zeros is that? What, 10 million magnification? You're actually looking at samples with electrons because the wavelength of light is too large. So if you look at it with electrons, you can see smaller things. A little more complex, but very, very, very cool. Yeah, we can look at contaminants. If there's a failure, we can figure out why. A lot of different things with microscopy. And this is probably one of the biggest things. This is accelerated death. This is, how do you take a part? You got 1 year to get it into production, but you need to know it's going to last for 10 years. How? Well, we send it down to Arizona. We got parts down there that are in special tracking machines. They track the sun as it goes across the sky, and they've got mirrors that focus the light onto our parts. So you can get 7 times the Arizona sun blasting onto your part. That's a really good way to kill something quickly. And let's say it lasts for 3 years. Well, if you do your modeling, it's like, all right, that's 15 years of real-world life. Great. Or we have these Atlas machines, like these huge boxes up here. That's where you have the ultraviolet light in the middle and all your parts surrounding it. And you can get 2 suns of UV light exposed to your parts 24/7. Or we've got these temperature humidity changes, or chambers. They can run a part from minus 40 Celsius to 70 Celsius in a matter of minutes. So you're cycling these things. That creates a lot of stress on the glass, on the seals, everything. And these things are going to start busting open. Because you might be, I don't know, driving down the road in the middle of winter. Your mirrors are really, really cold. You go in the car wash and it gets hit with hot water in the car wash. Boom. That part warms up very, very fast. Or you hit the defroster on. These things have heaters on the back. So that part goes from maybe minus 20 Celsius to 50 Celsius in 2 minutes. That's a lot of stress on that glass. We need to know that we can survive that. And then we have real world testing, but yeah. So the final group is production chemistry. This is a part of the applied materials group. These are the guys and girls that will scale up our processes to, whereas we might make something in a 1-gallon pot, maybe a 2-gallon glass vessel, they're going to scale it up to 200 gallons. This group is currently, I think their manufacturing space is maybe twice the size of this room. They are going to be increasing that to about 20-fold that. One of our entire expansion projects is getting more room and getting much larger reactors for all this stuff. So yeah, they're going to make 200 gallons of a reaction mixture, make 50 kilos in one batch instead of 5 kilos, just because we're growing so fast that they need to scale up. They're chemists, chemical engineers, they're technicians, degrees are all over the place, and we work with them hand in hand to get the products made. And then how do you get here to Gentex? Education, well, you guys are in the right place. You're at a good start. High school education might get you into production. Associates, if you don't get into a chemistry department right away, get into production. Make sure your associate's degree is on your resume. We will actually get resumes from the people in production and pick them right out of production and bring them into the groups. It might take a month, might take a few months, depends on how we have openings. If you're lucky, you don't go into production, you come right into a group. The great thing about going into production first, you figure out, see how all this is working, how these parts are made. You learn a lot. You're actually a lot more valuable to us if you have production experience. Now, other ways, you go bachelor's degree, PhD, whatever, but experience, whether it be at another job or you do an internship, you do an internship with us, you do an internship with a professor at your school. Some professors, I don't know if they do any research here or do research at other universities. During the summer, you work all summer in a lab. That's great experience. Not only are you going to interact with them, you're actually going to see how chemistry works in the real world. Because let me tell you, you learned about a reaction in a book. Guess what? It's not this plus these things makes this. There is a lot more to it than that. It's like cooking. You can just look at a recipe and make something and it's okay. But if you have the experience, you can make some really good food because you know the little tiny details of how to make things better, how to make things taste better, and how to not screw things up. Chemistry is exactly the same way. So research assistantships, internships, whether it be in a school setting, in a company. And then the other thing is networking. There are seminars given here, given at Grand Valley, given at Hope. Go to seminars when you have outside professors come in. Try to visit some of these companies, or when people like me come in and talk with them. Get to know some of these people. When I was at Hope College getting my undergraduate degree, my current boss came in and they wanted samples run on the NMR, nuclear magnetic resonance. So I got assigned to doing that. So I ran all these NMR samples with my boss, and we got to know each other and everything, and then I went off to graduate school. Didn't talk to him for a few years, just kind of, on and off emails here, there. Well, I'm getting near the end of my degree, and he emails me. He's like, hey, why don't you come on over to Zeeland? We have a position that just opened up. Okay. I grew up here in the Jenison area, so just outside of Grand Rapids. I had no intention, because you get a PhD, you don't expect to come back to West Michigan. There's very few companies that hire people of that education level. I have been at Gentex for 9 years. How? Because I had been networking. I had kind of interacted with my current boss, and you go to conferences, you network with people, you talk with people. You need to kind of somehow get your foot in the door, and that's how you're going to get a job. Because you just hand someone your resume, and you're going to be competing with maybe 100 other resumes. What's going to make you stand out? Well, if I already know you, that's going to help a lot. Because now I know your personality. It's like, would I enjoy working with this person? You can only get so much information out of a resume or even a single interview. There's those other little things that really, really help. And that's it. Any questions? Yeah?
The first one that came up was, I kind of ask this a lot just to get the feel around the chemistry industry. When you work, is your day mostly composed of team-based work, or is it individual work? And what types of other people do you work with if you are in a team-based setting?
Yes, is probably the best way I can answer this. My project right now is independent of the electrochemistry that most of my group works on. So I don't actually work with any of the chemists in my own group. It's not their specialty, but I am working with mechanical engineers. I am working with electrical engineers. I am working with some of the material scientists. I am going outside of the industry or outside of my company to other suppliers of parts, things like that. I am all over the board. My colleagues, they might be working on a project alone for a little while, but you're not going to do anything alone. You want to get anything, especially if you want to get into production, you're constantly working with others. First within your group to kind of get the product ready, and then we are not a chemistry company. Gentex does not make chemicals and sell it to the public or to other customers. We make our own chemicals to go into our own products. Well, guess what? The products, those are going to be based on software engineers, mechanical engineers, coatings people. We're working with those groups all the time. And you need to get out in the company. If you have experience as a chemist or a scientist with any type of engineering, that's a huge plus, because guess what? The two don't speak the same language. If you can go back and forth and you're comfortable with speaking the same language, heck, some of them are still dealing with the standard system, whereas we're metric. And it's like, that can cause some issues right there, because they're talking Fahrenheit, and like, huh? And then you're trying to do that calibration in your head, like, oh, okay, that's not that hot. So it's just kind of, yeah, it's very, very much teamwork. And it's not going to be strictly chemistry. It's very interdisciplinary. So if you can get an internship where you can actually have that experience, that is a huge help. So, yeah, was that enough? Okay. What's up?
Do you enjoy working more in the lab-based settings or coming out and doing speakings like this?
I love both. Obviously, if I'm going to get my job done, I had to do most of my work in the lab or in my office or in meetings. But I do give demonstrations to a lot of the local schools, because, you know, there's something about blowing something up in front of 90 little kids and having them all scream in delight. That's a lot of fun. Or talking with college students. That's like the frosting. It's like, that's the tastiest part, but you can't survive on it. So, yes, I do enjoy both. Anything else? Yeah?
Does Gentex offer internships?
We do, not a lot. Usually it would be like in my group or the applied materials group if you're more chemistry. We have some, like with the engineering groups and stuff, affiliations with various schools that, you know, you go to school for a semester and then you have an internship for a semester. Best thing is to get your resume and your experience to the HR department, and then they actually, anything that has chemistry related into it comes to my department, and we start thumbing through. We'll bring in people if we have openings, interview them, and an internship is going to be as intense of an interview as for a job. So just getting that experience is going to be very, very helpful. Even if you don't get the internship, is you're going to now know what to expect when you're looking for other internships or other jobs. Because, yeah, it's like if we can get 2 interns, that'd be great for us. But we do want to teach people, but we're also really, really busy. So we need to be able to bring in someone that is bright, that's smart, and can pick up stuff fast. So we can show you once or twice, and then boom, you're hitting the road. And yeah, you're going to come with questions, but if you constantly have to be babysat, that gets hard on us. So we do try to get 1 or 2 people, but it can get competitive. I mean, and you're at no more of a disadvantage than anyone else from any other school. If you have the experience, you take the classes, you're doing well, send your resume in. So, anything else?
Can I ask a question about the window?
Yes.
Is pressure a factor when you're designing that?
You'd think, because you go way up and you know the plane is under actually a high amount of pressure and there's very low pressure outside. And you ever someone see how thick that is? How would you feel if you're flying and the passenger next to you, her little 3-year-old pushes on the window and that cracks? You're going to flip out, aren't you? No. In a normal plane, there's a very thick acrylic plug that's actually bonded to the fuselage. That is the pressure plug. Then there's a plastic dust cover, just so you don't touch that thing and get it all greasy and whatever. We're actually in between those two, and we're closer to the outside plug because we still don't want anyone to flip out by pushing on that real thin plastic dust cover enough that you crack that. So I mean, this is not hard to break. And I think the glass is 0.95 millimeters, and there's 2 pieces, so it's less than 2 millimeters thick. And yeah, it's exposed to no pressure. It's mostly temperatures in the fuselage, so relatively comfortable. But because it's black and it's going to get hit by a lot of light, it can get very hot. You're not going to be able to touch it. But it's also going to be sitting on a tarmac in Dubai, and that thing can hit 150 Celsius, or it can be in Siberia, and it could be minus 40 Celsius. We need to be prepared for that. So, yeah.
Where do ideas for your new products come from? Is it just the whole team sits down and they yell ideas? Or?
That is one that we work on very, very hard as a team. There's mainly a group of 3 or 4 of us in our group. We sit down, we come up with a whole bunch of ideas, and then we have categories like, all right, is this thing even feasible? Would we be able to, if we had the resources to make this, would it be successful? Then it's like, okay, well, yeah, maybe. Do we have the resources? Yes or no? If we did this, do we have the capabilities in the company to manufacture this? Is it a big market? Would anyone else want to buy this? So we're constantly looking at that. That's the hard way. The easy way is fire department or your fire protection division comes to you. We need this gas sensor. What do you got? Well, we got nothing, but let us look into it. That's an easy way to come up with a new idea. Start looking into it. Yes, I think we can come up with something like that. Just give us time. There's a new project born right there. So it's either our own internal ideas or someone else within the company comes up with something, a need. Can you do something with this? Figure it out. And whether it comes to our group or it goes to another group, just depends on the nature of the product or the idea. And it might be not just your group. It might be you have to pull in 4 different departments and figure out how to do something. So, yes. Yeah.
Have you guys ever had, like, after the product's finished, where, like, dust or any type of materials got onto it and, like, did, like, white spots or anything like that?
Oh, yeah. We have all kinds of issues like that. Every single product, we actually have probably one of the most advanced vision detection systems in the nation, in the world maybe. We have cameras on every single step of every single part going through a whole process. So we cut the glass. We have a camera looking at it, looking for edge cracks. Because if you have a small, tiny little crack, well, it's fine now, but when you put it together in a part, over time that crack can propagate underneath your seal. Now you expose your internal gel to the environment, or it can actually just pop the glass right off from the seal. So we are constantly looking for defects. Every part we have before it goes off to our customer has been inspected every step from the very beginning to the very end. Occasionally you get one that looks perfect, pops up 2 weeks later. What are you going to do? Ideally, you fix the problem before it ever happens again. You hold on to the parts for 2 weeks, then you check them again. You got to figure that one out. So, but we do look for defects all the time. Yeah.
Would it still work if you, like, increase the volts in amps on?
Depends on how much voltage you hit them with. These are typically running around 1 to 1.2 volts. Occasionally you have a customer that decides they want to see how this works. They're going to hook it up to the 12-volt power supply from the vehicle. Ooh, look at that. It turns dark really quick. Yeah, you just ran so much current through that product that it might not show it right away. It's going to fail within a few days. Sometimes if they do it long enough, it actually cooks everything, decomposes some of the liquids to gases, builds up pressure, and then explodes. So no, you see that right there? That is a computer right there. This is a controller for one of these windows. It's a 2-layer board with enough computing power that it would compete with your laptop. And this is every single part. We have algorithms in there to control exactly how these things darken. We can drive them a little harder, back them off, whatever. We have the sensing parts in there to figure out what level it is, how dark is it, and it keeps very tight control on all our products. So we make millions and millions of these things. And we have a lot of electrical engineers designing this stuff, working with us to figure out what kind of parameters these parts can undergo. Because we know exactly what voltage these things need to be held at what temperature, to get whatever color or transmission level you want. And because you cook it a little higher, you're going to actually drive the compounds into other oxidation states that are a lot less stable. They get hit with sunlight, they're going to degrade a lot faster. So you cannot cook them too much. But yeah.
How hard are those windows to replace?
Not too hard. There's just basically a piece of foam that wraps around them, and then they're pushed in. They can pop out the outer bezel, put in a new one, and that's it. A few minutes. That's why they love this product. And it actually is lighter than the plastic shades. But profit margins are pretty nice on this. So we're enjoying this product a lot. Yeah?
Could your company do the whole design for the little computer circuit you got there too?
Yes. Yes. Everything. They design it. They can model it. How is it going to work before it's even built? They can make prototypes. If it tests out okay, boom, we manufacture it. We had, with the tsunami in Japan, knocked out a lot of electronic component suppliers for the entire world. It affected us a lot. We had to go and redesign several boards because all of a sudden, you have this whole board, you got every single part except for one tiny part that's the size of a pencil lead. You can't get that, you can't use this design. They will completely redesign a board just to get around that one part. And we can do that all in-house. Why do we manufacture in Zealand instead of, say, China? Well, okay, you think, yeah, it's cheaper to manufacture in China. Guess what? If there's a problem in China, you now have to get a team of engineers or scientists here in the US, get them to China, figure out what the problem is. All your instrumentation is in the US. Talk with people there. They figure it out. You fix it. 4 weeks later, the problem's solved and you're back into production. You just lost 4 weeks of production. I don't care if you're saving a lot of money on labor there. We are so automated that labor costs are not one of the factors in our manufacturing. Everything is made right here in the US. So, and we're very vertically integrated. We buy components like this, but we do all the glass coating. We make all the chemicals here. We build all these boards here. We assemble everything right here in Zealand. So,
Do you apply online for Gentex?
you can, yes. Just go to gentex.com and follow the pictures. And some of the local companies, you're talking about the billboards. One of my lab mates, his friend is in HR for Stryker, and we have a huge billboard right across the parking lot from their company. He does not like that at all because they've lost a lot of employees, and yeah, they just come over to Gentex. But we're trying to get the people we need. This downturn has been wonderful for us because we pick out good people, and there's a lot more of them. So, yep.
With the Boeing windows, you said that they would have control over the entire plane, all of them. Does each individual have like a little knob they can turn regardless of the light?
This thing right here is installed in the bezel right at the bottom of the window. So you'll have one of those, and you can see this is light, dark, and there's 5 different levels. That's just what Boeing wanted. You just hit the button, and you can control it to anywhere you want. And then this plug right here goes to the main network within the plane, and that supplies the power, but it's a network. So it talks with the main computer, which we design and build, and then they can control everything. So, yep, it's, yeah, we have, I think we're at 40 software engineers now, and they're all brand new to the company within the last 5 years. So, I mean, we've got mechanical engineers, software engineers, electrical engineers, chemical engineers, chemists, physicists, and then all your normal support people, whether it be finance, supply chain management, accounting, everything. So very, very diverse range of people. Yeah.
Who and how do you guys design a large-scale production system? I don't know how exactly to say it. The way things are manufactured on like a large scale, how do you manage?
Evolution. Evolution. When you're a small company, you don't have a lot of money. People are probably the easiest way to get things produced. So when I started, a typical inside electrochromic element, to make one of these, a line to make one of those had 40 people on it. Anywhere from putting the pieces of glass into the cutter cuts it out, they pull that glass out, they nip it to get rid of all the scrap glass, they grind the edges so that it's smooth, put it in the washer. Then other people take it, they put the coatings on, everything. 40 people. Now one of our typical inside EC lines has, I think, 5 or 6 people. We haven't laid any of those people off. We just have a lot more lines. They're all automated. We have vision systems on everything. We have got robots that control everything, moving things back and forth, putting on the epoxy seals, putting the glass together, putting it in the oven, pulling it out of the oven, putting it in a plant, and filling it. All automated, vision recording everything. We can tell where there's defects. We can have it all recorded. We've got terabytes of information. And that's all the engineers designing that. So, and it's taken years to develop that equipment. And all of it's custom, everything. I mean, you can't just go to some other company and say, hey, this is what we need. Sometimes what we'll do is we'll design a new piece of equipment, get all the kinks worked out of it, and then we'll send it to other shops, make us 10 of these. And they'll make us 10, and then boom, it's implemented on all the lines. And so, yeah, we automate everything now, and it really, really makes life easier. We can have 10 different part shapes. So this one's kind of a rounded corner rectangular shape. We can do longer, skinnier. Every manufacturer has a different shape. Well, it's like we need 10,000 of these. Program it into the computer. Boom, the line makes 10,000 of those. Switches over to the next shape, makes 2,000 of those. Switches over to the next shape, makes 1,000 of those. And it just, you don't have to do anything. It just plug it into the keyboard. That's all the engineers that we have maybe less production people, but we have a lot more engineers to kind of help with that, so that you have less production people but more automation. And so we might have less jobs than you would if you didn't have the automation, but those are much, much higher paying jobs. But you need to have the education to get there. So, and that's not how we started, but that's how we've gotten to that point. I mean, 22 million of these a year. That'd be a lot of people pumping those out every single day if we wanted to hit those numbers. So,
How much more do you think Gentex will expand?
19% per year. Gets a lot harder when you hit over $1 billion sales. So far, it's not showing any signs of slowing down. The aerospace market is going to be huge. We have a 45 to 50% take rate of inside elements in the US market. I think we're like 20% in Europe, and we're 5% in Asia. Asia is exploding. Our rightful share, we feel, is 100%. So just in automotive alone, we have got so much room for expansion. And now we have, say, a base mirror, like one of these. Just dims, nothing else, might sell to your customer for 20 bucks. All right, great. And every year they're going to want to say, no, this year we're only paying you 18. Next year we're only paying you 16. That's what happens when you work in automotive. Well, what if you come up with a new product where all of a sudden it's got a little LCD display hooked to a camera in the back? Now it's $120. Oh, I got to have that. Well, you're selling a $120 mirror versus a $20 mirror? Guess how many less you have to sell? You have to sell a lot less. If you still sell just as many, your numbers go up. And that's what's happened. So we keep on coming up with better products that the customers want even more. And even if they want to work the price down eventually, it's like, okay, and then there's another big step. And you just got to keep up with that. And the second you stop innovating, the company is going to have problems. I don't see anytime soon an issue with us slowing down. Right now, we actually would like it to slow down because production's been working 60, 80 hours a week. So just trying to keep up. So, yeah.
Just to piggyback on that, I was wondering what sort of like ramifications it's going to have with the windows in the automotive industry, not just the mirrors, also like for home construction and buildings and such. Is there any like projects like that in the works at Gentex, or is it feasible to do that? Is it cost effective to make that stuff for those?
That's a big argument. What do you notice about this window? One size. This plane, one window. Can you see about that shape? Is that flat?
Yeah.
That's flat. What do you know about your car windows? Are they flat? They're curved. You know how hard it is to take two pieces of glass, have them curved, and they've got to be parallel within microns across the entire surface. If they're not, you're going to have light spots, darker spots. If it's a mirror, you have double image, where you might see, instead of a pair of headlights, you see two pair of headlights. You have to be perfect. We've gotten really, really good at glass bending, but we're bending parts like this, not like that. Automotive windows a lot bigger. Is there another technology? I'm not going to say we're not working on it, but sunroofs, same thing. Car windows, bent glass, sunroofs, bent glass, architectural. If you want to know what it costs to outfit a Boeing 787 with 100 of these windows, you don't even want to know what it would cost to put in your house. Now, the other problem is with a house, or more importantly, we'll say a building like this. That window and that window, they look about the same size. They're not the same size. They might actually be, one might be a ½ inch longer and 2 inches taller because the building's not perfect. When the glaziers come in to put the windows in a building, they're basically measuring. They go down, they cut the glass, they build it into an IG unit, and then they go and install it. Every single piece is custom. We cannot do that with this type of thing. It's way too complex. The chemistry can handle it, but the cost would be exorbitant. And so right now, no. Are we working on it? We are working on it. So is it going to be right away? No. It might be another 5 years, might be another 10 years. But again, that's just another market that you could get into. Because it'd be pretty cool not to have to go up and pull those shades down, but to hit a button and boom, they're dark. So.
What about
Trains, limos, cruise ships. We've talked with people. So there's a lot of demand, and we've turned away a lot of people. There's only so much we can handle right now. So, yep. So another cruise ship. I mean, nice little circle. Fit right in that, right?
As far as your patents go, is that something that you keep renewing so that, like, you're right on it?
You figure 17 or 20 years for each patent?
Right.
Okay, well, that's great. You know exactly when that's going to end. You get to make a big improvement, you patent that. Now you got another 20 years.
Okay.
And boom, boom, boom. You don't innovate, all of a sudden, boom, you have a product that everyone else can make.
Right.
You're not necessarily going to stay in the front anymore. So we are constantly improving these things, constantly patenting everything. So,
How do American companies in the same kind of field, Gentex, and how are they comparing on a worldwide basis?
It really depends. Some have gotten into a lot of debt. Some are in very, very competitive markets. What we have done is we've decided, even though we're big or getting big, is to stay very, very focused on what we do and what we do well, and not get into completely different markets. The second you do that, you start diverting more resources to that, and you can't improve what you're good at. And it actually can weaken the company. So one of our biggest competitors for this type of technology, well, for the car mirrors, is Donnelly or Magna now. They got bought out, and they're in Holland. They're 4 miles down the road from us. Between Magna and us, We hold 97% of the world market in dimming technology. And it's like, what are the chances of having the two largest companies in this field within a few miles of each other? There's been a lot of bad blood, a lot of patent issues and everything, but and a lot of employees swapping. So, yeah.
So why exactly Michigan? I mean, most of these companies show
Yeah, no, it's a good question.
there's a lot of other chemical companies that are apparently in Michigan.
No, there's not much. You got Perigo and a couple smaller labs. There's Pfizer's gone. They moved out of Holland. It's just automotive, and there's a lot of entrepreneurs in this area. Everyone wants to start their own business. That was definitely a factor. It's kind of a unique area, and then both of us developed kind of simultaneously in this field is kind of a unique situation. I couldn't tell you why. So got a lot of good schools in the area. That's helped. And you got MSU, Michigan, Grand Valley, Grand Rapids, Hope, Calvin. Got a lot of very, very smart people. And being tied with the automotive market helps. But being over here helps us actually get a little more respect than if we were on the east side. So, and they always love it. We have a couple Lear jets that we will actually fly over, pick up some of the guys from GM or Ford or whatever, and fly them in and give them tours and then fly them back home. So you can do things like that when you save your money. And that's the other thing, is this area is very well known for saving money. And there's a lot of millionaires and very well-off people in this area, and you would never know it either. They don't flaunt it. So yeah, it's a unique area. It's a great company to work for. It's a little crazy right now, but yeah, it's just zipping along. So is that it? Anything else? No. Thank you for listening to me blab for a while. So.